this is me. This is our contact information. I always make a big deal out of this, and rightfully so. General Air Products is very customer responsive. It's something that we pride ourselves on. General's my family's company, and it's something that passed down from my father and my grandfather and stuff. Is that we're always to be customer focused, and that means when you reach out to us, we reach out back. We always respond to you. So hopefully, I know we have a lot of people who have been coming back to our presentations here. If you've had that experience, please pass that along to others. But that said, if you have any questions about my presentation, anything about air compressors, anything about 13D pump and tank systems, I'm genuinely always happy to have a conversation about those things. So please don't hesitate to reach out at my email address there or by calling our 800 number there below. Manufacturers of air compressors, dry air generators, nitrogen generators. We'll touch on some of those products, but really today we're going to be focused on codes and standards that surround air supplies, and then we're also going to be a little bit, if time allows for it, we'll get into what the differences are between retail air compressors and a fire protection air compressor. And we also offer the line of 13D pump and tanks. Again, today's webinar, we're going to cover air compressor codes and standards, and then we'll talk about what is and what is not a fire protection air compressor. Since we'll be referring to NFPA codes and standards, these are our interpretations, and I ask people to challenge those interpretations. If there's something that you have a question on, or if you don't think it's right, please let me know. I mean, we want to be right. So and the best way to be right is to be challenged on things, I think. And as we're challenged on them, and if we're still right at the end of the challenge, then that's great. And we've learned that we're in solid footing. And then you've learned something new. But if you ask a question and I'm wrong about it, I very much want to change my presentation to make sure that it's right. So we invite all criticism and question to the things that we put out there. We'll be going over NFPA 13 and NFPA 25. We'll be using the 2019 edition of 13 and the 2017 edition of 25 as we go through this. So let's start with NFPA 13. Air supply is mostly in Chapter 8 of NFPA 13. The first term that we come across, or the first section that we come across of relevance to the air supply, is where the term air is used in the standard. It will also include the use of nitrogen or other approved gas. This was added as nitrogen came onto the market, and it was a way for them to kind of catch all if there's any future technologies or any other alternative technologies that come out. This can be a catch-all. So anywhere you see the term air in 13, you can substitute the use of nitrogen. Maintenance of air pressure. Air pressure will be maintained on the dry system throughout the year. So the idea here is to prevent somebody trying to have like a seasonal dry system. This is something that very much will come up right now. I mean, we've experienced it before when there's major storms or flooding in areas. People start calling us up and asking us, well, can I convert my wet system to a dry system? And after winter storms in like Georgia a few years back, these winter storms in Texas this time, I expect that we'll get several of these phone calls. And people are often asking, like, can I make it a dry system part of the year and make it a wet system the other part of the year? The point of this 8262 is to make sure that it is, you either have a dry system or you have a wet system, but you don't have both. It doesn't transform back and forth. So 82631, the compressor or the compressed air shall be from a source available at all times. This is really what mandates what the equipment should be like. So it begs the question, does this mean that air cylinders are acceptable? Air cylinders are an acceptable means, as long as it is a compressed air source available at all time. You got somebody with a bike pump who's at the ready next to the thing, that's apparently acceptable. It's unfortunate, but it's acceptable. So it's, things in the standard that, obviously it's always an evolving document, but a source available at all times does cover it. So by the book, that's what is capable. But, obviously from a convenience standpoint and from a practicality standpoint, an air compressor is the way to go. So air supply shall have the capacity. So what should we do with the air compressor? How do we size the air compressor? How do we make sure that we have the right air compressor in there? And that's really what this next section speaks to. 82632 says that the air supply shall have a capacity capable of restoring normal air pressure in 30 minutes. So when we use, so this in conjunction with the size of the overall system, I mean, really what we need is the size of the system, the time to fill the system, and that's going to tell you what the flow of the compressor needs to be. There's an equation for that. We do another presentation where we get into the sizing and how to size fire protection air compressors, where we get into that equation and how that equation works, and the multiple ways that you can size. I think we call it basically easier and easiest ways of sizing these systems or sizing these compressors. So, but the 30-minute fill time is part of what says this is how big your compressor needs to be. In the annex for this section, it's important to call out when a single compressor serves multiple dry systems, the 30-minute fill time is based on the largest system. So if you have multiple systems, if you have, your air compressor is governing 3 systems at that point, and we'll get into the code for this, but you would have a tank-mounted air compressor with 3 air maintenance devices, 1 for each system. If of those 3 systems, one of them is 1,000 gallons, the other 2 are 500 gallons, you have to size that air compressor for the 1,000 gallon system, 30-minute fill time. And then the other 2 will fill in less than, presumably closer to 15 minutes, if that compressor is sized properly, but each one of those will then be filled within 15 to 30 minutes, given the size of the compressor and the size of those systems. Something else I'd like to bring up here is that there is no section in the code that speaks to how many systems can be attached to one air compressor. It's something that, again, I'd like to address at some point in the codes and standards, but it's a tough argument to make. It gets fairly complicated with sizing of air compressors and such. But that said, we want to protect, General Air Products wants to protect the integrity of the air compressor lasting as long as possible. See, air compressors don't really run on years. They run on hours. How many hours does the compressor last? And a fire protection air compressor is going to last anywhere from 5,000 to 8,000 run hours. We're going to talk about this a little bit more when we get to what is and is not a fire protection air compressor, because a retail air compressor is meant to last about 500 hours, as opposed to a fire protection air compressor, 5,000 to 8,000 run hours. So those run hours are going to run out the more systems that you attach to it, because there's going to be more and more leaks. So while there's no rule that says that you can't put one air compressor on 20 systems or one nitrogen generator on 20 systems, it's a really bad idea. It's a really bad idea because you're going to make that air compressor or that nitrogen generator run like crazy. So it's something that I really recommend against doing. At any rate, that's, yeah, so our single system, we recommend, instead of letting it go on infinitely, we recommend no more than 3 systems per compressor, and that way you can maintain your compressor lasting 10 to 15 years roughly. You can expect that it will. But outside of that, yeah, the more systems that you add. So what we really kind of tell people to do is, if you're coming up on 4, 5, 6, 7 systems, something like that, and you're trying to figure out how many air compressors, give us a call. We're more than happy to, I mean, in an instance, let's say where the largest system is 1,000 gallons, but all the other systems, the other 4 or 5 systems are all 200-gallon systems. Well, maybe then that case, it's not going to be so bad for the compressor. And that's something that if you run by us, we'll be more than happy to tell you. We always want to help you find the most cost-effective solution. And with our product line being air, dry air, and nitrogen, we have all the air supplies that you can hook up to your dry system. So we're going to help you find the most economical way to approach it. All right, so 82661, the air supply shall be from a dependent plant system or an air compressor with an air receiver. Okay, so basically it's saying, well, one, this brings up the idea of plant air or the plant air system. And something that's interesting to know is that there is no definition for what plant air is. at least not to my knowledge. I've not seen one in the code book, but I've also been asked to research it outside of NFPA 13, and there's no real mention of what plant air is. So that's something that's begging for a definition. And an air compressor with an air receiver. So 82661 says you always need an air receiver, but then 82662 says unless. Okay, so it's you always need an air compressor with an air receiver unless the air compressor supplying the dry pipe system has a capacity of less than 5.5 CFM at 10 PSI. At that point, you need an air receiver, and you won't necessarily need an air maintenance device. So that's an important distinction there. It's when you need an air maintenance device and when you can use a riser mount compressor. And most systems are small enough that you can use a compressor under, most dry systems and pre-action systems are small enough that you can use a compressor under 5.5 CFM. And I'll show you that. I think it's on the next slide here. Yes, it is. Okay, so here's a good example. This is a clip from one of our cut sheets, and you can see that center column, average CFM, right? We use that as our metric there. If it's at the average CFM is below 5.5 CFM, then you're in good shape. So the average CFM of the OL 430 is 5.21. So up to the 3/4 horsepower of the OL 430 in this instance, we do not need an air maintenance device. But you go north of that, you go into a 600-gallon system, and you're going to need that because the next size up is 7.46 CFM. Uh, 82663 says the air supply connected to more than one system shall be connected to allow individual maintenance of each system. Important to note. So to clarify, in the next section there, it says that you need an air maintenance device for each riser, not each compressor. So it's an important distinction. Again, riser mounted compressors don't typically they shouldn't have an air maintenance device on them. So now we're talking about tank mounted air compressors, and if a tank mounted air compressor is hooked up to one riser, you need one air maintenance device. If a tank mounted air compressor is hooked up to 3 risers, you need 3 air maintenance devices. All right, so dealing with the system air pressure, NFPA 13 recommends using valve manufacturer's literature to set the proper air pressure. Every valve manufacturer has specs in there that I know of anyway, has specs in there for what the ratio for the valve is of air pressure to water pressure. But the code goes on to say if the manufacturer does not provide an air pressure recommendation, there is one here. So it says to divide the maximum static pressure by the differential ratio and then add 20 PSI as a safety factor. So if you look at the math below, using a static pressure of 85 PSI and a 5-to-1 ratio, we're at 17 PSI, and then you add the 20 PSI for a safety factor and you put you at 37. And that's why, because those are all pretty standard ratios and static pressures commonly found. That's why if you ask us what we set our standard pressure compressors at, standard pressure compressors are set at 40 PSI. So we actually bump it up just a touch more with some extra pressure there because the pressure switch has play, especially mechanical pressure switches have 2 to 3 PSI differential, or not differential, basically a fudge factor. It's a mechanical operating thing, just like a pressure gauge is going to have a little bit of play. A pressure switch also has a little bit of play. So that's why we round up to 40. Just something to note, again, in another part of the 82633, for refrigerated spaces maintained below 5 degrees Fahrenheit, you're permitted to use a 60-minute fill-up time as opposed to a 30-minute fill-up time. But that's only in refrigerated spaces under 5 degrees. Okay, so if it's a cooler that's at 30 degrees, you're still at 30-minute fill-up time. And even a lot of the freezer rooms and stuff are at, say 20 degrees or 10 degrees. So it's a rare bird to have one at 5 degrees or below, but it is something to keep in mind. Another statement on refrigerated spaces. This is something that was new information to me, and I think it's really important to call this out. We do presentations on cold storage facilities and air supplies for cold storage facilities, and that's where when I was doing some research for that, read this section of the standard, and I think that it's a really important distinction to make. As a manufacturer of air and nitrogen and dry air, General Air Products, as General Air Products is, we really want you to understand when you can use different technologies and when it's best to use different technologies. And in freezer rooms and refrigerated spaces, the dry air pack or the dry air generator is always the best way to go. You know, that's that whole presentation summed up in one line there for you. I might have just saved you an hour. But that said, air from the room of lowest temperature to reduce moisture content. So when we're talking about air supplies, there's 3 acceptable air supplies that the standard calls out, or ways to approach air supplies for freezer rooms and cold storage areas. Number 1, air from the room of lowest temperature to reduce moisture content. I capitalized reduce there because it's important to note it does not eliminate moisture content, it reduces it, which means that you do not eliminate the instances of ice plugs as the air goes from the wet air goes from the air compressor and into the system. Because at that ambient air freezer room interface, that water vapor is going to freeze to the pipe and eventually cause an ice plug. And even the standard is saying it will reduce that moisture, which means it will potentially reduce the amount of moisture going into the system, which will reduce the instances of ice plugs, but it will not eliminate the instances of ice plugs. So that's really important distinction there. You will still get ice plugs if you use an air compressor on a freezer room dry or pre-action system. Okay, it's just a matter of reducing those instances, which again, I go back to the standard and say, do we really want to reduce ice plugs or do we want to eliminate ice plugs? Because I would think that the reduction of an ice plug means that, you know, you still have an ice plug, which means you have a sprinkler system that may not be functioning properly, and you may not get water to. So just again, food for thought for everybody here. The next acceptable air supply is a compressor dryer package that's listed for the application using ambient air. That is the dry air pack from General Air Products, or a dry air generator. Ours, to my knowledge, is the only listed FM approved compressor dryer package. There may be other ones out there, but I do not know of them. But you know, we've been making the dry air generator, the dry air pack, for almost 30 years at this point, and it was made specifically to eliminate ice plugs. So as long as you maintain that unit properly, you will eliminate ice plugs because of the way that unit functions. The last one on there is compressed nitrogen from cylinders used in lieu of air. This is important because we see a lot of people pushing to put nitrogen generators into freezer room applications, which, again, if you come to my presentation, I explained to you why that's not a great idea from a variety of angles. And I always like to say is that I wish that it was the right solution, because then I could stop making the dry air pack, and as a manufacturer, it's easier to make less product lines. So if I didn't have to make the dry air pack anymore, I could stop making the dry air pack and just make nitrogen generators, and that would be a whole lot easier. But the fact is, the dry air pack and dry air generators are the best solution here. So if that's something that you have an interest in and something that you want to know more about, come to one of our cold storage webinars coming up I want to say we're going to schedule one for April or May. But at any rate, what it does not say in these 3 examples is it does not say nitrogen generator. It says compressed nitrogen from cylinders. So what, at best case scenario, I think you should be asking your AHJ if it's permissible under this section of the code to use a nitrogen generator before you go and install one in a freezer room. So I would certainly use that step of caution at least. But I would also say that if you are using a nitrogen generator, you would have to use air, because, you know, again, we're going back to the other part, air or nitrogen, right? As it says in the code, it can be air or nitrogen. A compressor dryer package is not a nitrogen generator. Air from the room, and also nitrogen cylinders are not a nitrogen generator. So that goes back to our first one, air from the room of lowest temperature to reduce moisture content, which means that at best case scenario, if you're allowed to use a nitrogen generator, and again, this is my interpretation of this, But you know, for anybody who is interested in the letter of the law here, which I imagine anybody is if they're in the fire sprinkler industry, air from the room of the lowest temperature is saying that also you're going to have to pull your air for the air compressor on your nitrogen generator from the, you're going to have to go through the wall and pull the air through from the freezer room. So just again, something to keep in mind there. Air compressors and air supply connections under NFPA 13. Minimum pipe size for the connection from the air supply to the dry pipe valve should be 1/2 inch. Really, really important. You need to get that full airflow out of the compressor, and most compressors are coming with a 1/2 inch connection out of their compressors. That should not be reduced there. You're going to get a lot of build-up pressure at the compressor as it can't get the air out fast enough. It has a high flow and it just can't get it out fast enough. So you're going to have your safety valve tripping. You're going to have short cycling of the compressor if you do something like what's in this picture, which is a 1/4 inch piece of copper coming out of the compressor there and going right into the dry pipe valve. That compressor is no doubt in my mind short cycling and or building pressure and firing off the safety relief valve. So I would highly recommend, you know, again, anybody, not highly recommend, I'm saying that you need to use a 1/2 inch connection. That's one of the reasons why for General Air, we include a 1/2 inch, a 1/2 inch NPT 30-inch long stainless steel braided flex hose with all of our riser mounted and tank mounted air compressors. There's a variety of reasons we do that, but that's one, is that we give you the start. You don't even have to think about it. You just put in the braided stainless steel flex hose and it comes with the unit. Actually, let me go back to that. Oh, and another thing here, you can see, and this is something we're going to get on, but I like to call it, whoever wired this up, they did from the pressure switch. You can see this line coming down here and going right into an outlet. Whoops. And going right into an outlet over here. Tell me how easy it is to just unplug that by accident, just by bumping into it and working on it back there. That's going to be an issue at that installation as well. And that leads us to this next section, which is some new additions to the 2019 standard, ones that I'm really, really happy to see. And that's 82665 that says that the air compressor shall be installed basically according to NFPA 70, Article 430. That has to do with motors and motor wiring. But now there's an additional aspect to this, in that the disconnecting means cannot be a light switch or a plug and cord. So essentially, this plug and cord issue down here is no longer allowed. Okay, it has to be hardwired. The light switch is another issue as well. So here we have a plug and cord, and another thing too that I'll say, if a compressor that you're using has a handle on it, it has wheels on it, it is meant for not to be permanently installed. It is meant to be moved around. So when you know that compressor was designed for a very specific application, and it's not one that is for permanent install. Okay, so there's and you know the handle, the wheels, that's what's telling you that. Then additionally here we have this coming right out of the pressure switch, just like in the previous picture, going right into an outlet on the wall. Now, here's a couple reasons why this is a problem. One, an outlet in the wall might be part of a circuit that has many other pieces of equipment on. And if the air conditioner kicks on, that's on that circuit in the next room, blows the circuit, well, now all of a sudden your compressor is no longer functioning. So it doesn't offer that kind, and now your compressor is potentially down, and that can lead to your system tripping. So this is really good that they've isolated this to, it should be a single circuit, dedicated circuit. It should be an industrial use disconnect and permanently installed. Here's another example of a bad one. I mean, they went to great lengths here. They looks like they took the wheels off of the back and nailed it to a board. You know, getting creative here. We're using our carpentry hobby in the middle of this, which is, you know, I guess fun and unfortunately code compliant up until this new part came in. This one here has the plug and cord going into the wall, it may be wired to, I would say it's probably wired down here to this, an outlet on the other side. And then they have a light switch here that says air compressor, basically just calling out that that switch is for the air compressor. Now, here's another reason why this is a bad idea. One, there's two switches on there. So one's for the light and one's for the air compressor. Somebody just goes in there and mashes those buttons, they're going to shut the air compressor off. And you're not going to know about that until there's an alarm or the system trips. Another issue with hooking up air compressors to light switches is that a standard use light switch is good for anywhere between around 7 amps, 7 to 10 amps. And most air compressors, especially on startup, pull way more amps than that. So if a compressor starts to short cycle a little bit, it's going to trip the, it's going to fry the light switch. It's going to trip the breaker. If the, yeah, so it's just, they're not designed for that. You need something that, a switch that is meant for high amps. This one, I just love the show because it's, well, I think it speaks for itself. Somebody attached a light switch right to the pressure switch. Again, the best I can say is this is no longer allowed. So this is what a good install should look like, okay? A good install will look like, first we have the industrial duty disconnect up there. And again, we're not into the industrial duty disconnect business. I don't care what brand you use or whatever. We can get one for you if you need one, but really you go to your local electrical supply house or the electrician does, and they put that up. And that's going to cover you on the amperage end. It's also going to cover you on the standpoint that no one's going to accidentally shut that thing off. Right there, it's in the off position, but no one's going to accidentally push that lever down. That's an intentional action. We can also see that it's not plugged in, right? Our power is coming through the industrial disconnect. Additionally, and this is part of the NFPA 70, is that the installation location is within 6 feet of the electrical disconnect. So you shouldn't be running across a football field between the compressor and the disconnect, okay? So this is what this should all look like going forward. Going forward, additionally, these are not very easy options because there's a lot of customization that you're going to have to do in order to get these to work. All right, so let's talk about leak rates for a few minutes. This is another thing that affects your air supply technology. So I want to talk about leak rates, and there's two parts of code that are called out here. First and 13, permitted leak rates for new systems, tells you whether they're called out in 28221. So for new systems, we're allowed a 1.5 PSI leak for over a 24-hour period. And I can tell you that even in a small system, that is a very, very small leak. There is little tolerance there, and that means things got to be put on tight. So, again, something to keep in mind there. Existing systems, as per NFPA 25, are allowed a 3 PSI leak over a 2-hour period. There's multiple ways of quantifying the allowable leak rate in NFPA 25. This one's the most straightforward to explain. So that's the way I go with is 3 PSI over 2 hours, which works out to 36 PSI over 24 hours. So why is this relevant to you? Well, it's relevant to you insofar as when you use especially when you use a compressor that is attached to a dryer, but moreover, a compressor that's attached to a nitrogen generator, filters restrict flow. So you got to understand that as the air goes through the dry air unit, we lose about 10 to 15% of our flow as we go through the desiccant beds. And we calculate all that in there. So 10 to 15% isn't a big loss. So that's not too much. It doesn't really present much of a problem, but in fairness to the argument itself, there is a restriction of flow there, and I want to make sure that everybody's aware. And when we calculate the flow of the dry air units, we calculate it with that loss already there. It's not like we just say, okay, well, this compressor attached there is good for 20 CFM, so it's a 20 CFM rated. It's not. It's rated for the flow that gets to the system, not coming out of the compressor end. But additionally, you see here, and this is part of a presentation that we get into our air supply decisions, and we get really in depth with this stuff, and I'm not going to right now. But I wanted to show this slide because it shows the difference when we're sizing for a 2,000 gallon system or a system that's in this criteria. When we size these compressors, these compressed air technologies, you can see that there's a huge different inflow. The correctly sized air compressor is about 24 CFM. The correctly sized dry air generator is 21 CFM, and the correctly sized nitrogen generator is 0.6 CFM. So leak rates are of very high relevance when you're only putting out 0.6 CFM. This is a real problem point for nitrogen generators. And it's just something to, again, it's, you know, if it wasn't good technology, we wouldn't be building it. But that said, it's something that's a real vulnerability to those types of equipment and to the systems. And it's something that contractors and end users really need to be aware of. There is a significant airflow loss as you go through a nitrogen membrane. All right, so let's get into 25. The first thing I like about 25 is just, you know, I mean, it really is 25 overall is just about checking the basics. What is really going on in these systems? You know, is everything okay from a 10,000 foot view? You know, we're looking at these things and we're just making sure that, you know, everything is basically functional. And one of the ways that you can affect that when it comes to your air supplies, and we'll be talking specifically about 25 in the air supply category, one of the things to remember is where you put your air compressor is going to have an effect on how well it performs. So in the picture that we're looking at, I mean, obviously this thing is really corroded, right? Externally corroded. It was placed not far from a salt body of water. And this compressor is only a couple years old at the time of the picture. You know, so it's eating away at the outside of this compressor. That compressor is not going to last long there. So it might be a good idea to run that compressor further away and run a piece of pipe down there because to be closer to the body of water because it'll be protected, it'll be galvanized, and it'll be protected from that. And you'll move the compressor away so that it will be protected over time. Another instance of this is like putting these compressors into like janitor's closets where there's ammonia or there's chlorine, things like that that are on the intake of, you know, sometimes it's in a pool room, stuff like that. Well, whatever's in the air in that space is going to get pulled into the intake. So if that's ammonia or if that's chlorine, that's going to go into the intake and start to rot out the inside of the compressor. So it's something else to keep in mind of where you place the compressor, and that's something that you'll be looking for when you go to 25 or you're carrying out the directives of NFPA 25. So in 25.5424 calls out air compressors used in conjunction with a dry pipe sprinkler system shall be inspected, tested, and maintained in accordance with Chapter 13 and the manufacturer's instructions. That's what lived in 25, I think, up to 2017, or the 2017 edition. That was basically what it called out for air compressors at that point. And really what that means to most people is I don't have to do anything. So what was added in the 2017 edition was here's what you need to do. And that's going to be defined in these next sections, 13, 10, 2, 3, and 4. The inspection is going to call out for the, and this is calls out for a monthly inspection. Air compressor is free of physical damage. So has the air compressor been hit with a forklift or something like that, okay? Is the power wiring to the air compressor free and intact of physical, intact and free of physical damage, geez. So is the air compressor intact and free of physical damage? Again, we're just looking to see, did this thing get run over? Did the wires get pulled out or pulled away from the machine? You know, is there any vulnerability there? Piping from the air compressor to the fire protection system, again, intact and free of physical damage. Is the compressor anchored properly? Again, can't stress that enough. The the anchoring of these things is really important because over time, I mean, again, an air compressor vibrates, right? It vibrates, and it's constantly moving every time it runs. If it's not anchored properly, you're going to get to a point that it starts to shake around, move around, and come off of its anchoring, whether that anchor is a riser or it's anchored to the concrete floor. You're going to start getting it vibrating violently, and you can end up having the compressor fall off the riser. You can end up having, again, in the instances of tank mounted units, what we see is the more anchoring that is a problem, like the more it is loosely anchored, the compressor shakes around that much more. As the compressor shakes around that much more, the motor and pump are misaligned, which misaligns the belt and pulley, and that wears the belt and pulley down. I mean, all of these things seem far-fetched, but they happen over time, and they happen all the time. So that's something really important to keep a look at, is the anchoring of it. And we include vibration pads with all of our tank mounted units. We include a riser mounting bracket with all of our riser mounting units with the straps that can hold up a truck. So, I mean, everything is there to be done to be done correctly. Out of the box from General Air Products. So just, again, make sure that you're checking in on that to make sure that what was done right to start continues to operate properly. Last thing is to check the required amount of oil in the oil reservoir. All of our lubricated units have a sight glass on them, and the sight glass should be filled halfway. A couple things at this point that I think it's good to bring up. One, when we ship our lubricated units, we do test them before they go. We test everything before it leaves our building to make sure it's working properly. So to do that, we drop in a little bit of oil so that we don't hurt the pump. When it gets to a job site, sometimes, after shipping and everything, that there's a little oil splashed up on the sight glass. Just make sure that, you either take it out and wipe out the sight glass and then put it back in. But I can tell you that if you get it out of the box, you open up a box, there is not enough oil in there to run it. We include the oil that you need with the unit. It's another thing that we include. So just, make sure that you're adding the appropriate amount of oil. The other thing that I like to bring up at this point is an oilless air compressor does not need oil. It is not oilless because it doesn't have oil yet. It's oilless because it never needs oil. And that comes up quite a bit. I want to say, and this is kind of something that I like to bring up with our customer service, is that, there's people who are very brave enough out there to call us and ask us where to put the oil in the oilless air compressor. And that happens at least, once a month or something. It's fun for us. And we try to politely answer the question by saying that you do not need to put oil in the oilless air compressor. But I try to bring that up, not to make fun of those people, but to say, look, we get questions like that all the time. Your question is a good, valid question. Call us with it. We're happy to take your phone call. We answer questions like that all the time. We can answer your question too, no matter what it is. We're not keeping track of who called us with what ridiculous question or whatever. You just get the answers that you need. And if that person needed to know where to put the oil in the oilless air compressor, I'm glad they called us before they just started pouring oil into it. So always a good thing. Here's a good example of inspection. Hopefully that picture comes through well, but what you can see is at some point this pressure switch got smashed. You can see that the cord here is coming out of the switch and is pulling the wires with it. And somebody took some sort of zip tie and zip tied the cap back together and onto the unit. This should not be there. This should be good for a pressure switch replacement at this point. This thing has been, it's going to fail soon. Just because they basically duct taped it back together, so to speak, doesn't mean that it's going to last. That's going to be a problem. And if you come across that, it is not free and it is not intact and free of physical damage at that point, and it should be. Okay, so testing. You should be tested annually, the compressor, and these tests should include that the air compressor operates as intended on the pressure drop. So that's our differential and our set pressure on our pressure switch. Our standard oilless compressors are 2744. So or is it 3044? Well, whatever, it's only a couple pounds. So let's call it 3044. You want to make sure that it operates down as the pressure is lost. The compressor turns on at 30, and then as it brings the system back up to pressure, it turns off at 44, or whatever the switch is supposed to be set for. That's the idea. Air compressor restores normal air pressure in the fire protection system in the required time frame. So again, we got a 30-minute fill test there. And then, but we say that in that manner because you could also have the freezer room that's at negative, or that's at 5 degrees or below 5 degrees, in which case you have a 60-minute required time frame. The air compressor does not overheat while running. This is a tough one, and I wrestled with this as we were going to get this into the standard a little bit, from the standpoint that when you need to understand that when motors run, they get hot, okay? Hot to the touch. Like, I mean, if a motor's been running for 30 minutes, for the 30-minute fill-up time, you're gonna burn your hand when you touch that motor. Additionally, air going into the system from the air compressor, or air on the outlet of the air compressor, is anywhere from 200 to 400 degrees as it goes through the compressor and comes out. So the outlet of the compressor is going to be hot as well, the more that it's running. It's up to you to figure out how hot is too hot, right? If we're seeing that thing glowing, it's too hot. If you're seeing a lot of discolored paint, you should call us or call the manufacturer. But call, you know, if in the instances General Air Products, call us and we can help you troubleshoot to figure out how hot is too hot. It's a little bit subjective, but I think it's a good, ultimately anything that gets people paying more attention to the air compressor I'm for. Just because it becomes problematic, and the more that people are keeping an eye on things, the less problems will occur. But that said, overheating while running is something to keep in mind, and you know, in that it's somewhat subjective. And again, never hesitate to call us if you want to get into more detail with that. Next section to go over is the maintenance. Maintenance shall be maintained in order in accordance with the manufacturer's instructions. And we have, I think I have some slides here with our instructions on them, which I think we've recently changed. So we might, I might skip over those because we've actually pushed them out a little bit. But we'll take a look at that. And then compressors requiring oil shall have the oil replaced on an annual basis unless the manufacturer's instructions require more frequent replacement. So I know we call out annual oil replacement at this point. Again, it's always nice and neat to do everything in terms of years. And we were talking about this earlier in the presentation. And I wish everything was nice and neat in terms of years, but the problem is we recommend a 1-year oil replacement. But if you put our compressor on a very leaky system, right? It's an existing system where the compressor's running a lot. That means that you're probably going to have to change the oil more often. So you really have to get used to your own systems there to determine how often you need to change the oil. Usually when you first install a new system with a new air compressor and it has a very low leak rate, 1 year is more than sufficient for oil change. But if, you know, let's say 10, 15 years down the road and you're putting a new compressor on there, that system now probably has a lot of leaks and it's probably running a lot. You probably need to change the oil more than once a year. It's, again, something to keep an eye on as you maintain systems, especially for you service folks out there. All right, before we get to the next section, I figured I'd stop and make sure that there's no questions, or if there is any questions, I try to answer them. So Dave, how are we looking on questions?
I just have one left over right now, Ray, just because I can't answer it, but I'll let you take a shot. This goes back to when you're talking about leak rates, and it just says, for quick estimation, what is the estimated air leakage rate per 1 meter of pipe per 1 fitting?
The air leakage rate of what?
Per 1 meter of piping per 1 fitting. So it looks like he's looking for a way to kind of calculate an average leak rate based on how much pipe.
I got you. Again, it depends on how much corrosion is going on in that pipe and how tight that fitting is. I mean, and I know that's not a good answer. And I guess what I'm trying to say is there isn't a good answer. It doesn't stack up nice and neatly there. There's allowable leak rate for the entire system, but one section of pipe might leak more than another section of pipe. One coupling might leak more than another coupling. And it's usually not the coupling, it's the It's the gasket that dry rots and such. So unfortunately, there's no average amount or way to do a rule of thumb there. The rule of thumb is just looking at your overall system leak rates.
Okay, great. One more just came in.
Sure.
That just says, I didn't see anything on draining the tank for condensation. Is there anything in the codes that speaks to that?
There's nothing in the standard that speaks to that, but that would be in the manufacturer's instructions. And I'm very glad that you bring that up because that's something that I should call out. I'm actually going to make a note to do that. We should add a slide about that, is draining tank. I'm writing that down. Yes, no, they actually, there is nothing that's called out that you should drain the tank, but you definitely should drain the tank. A difficult aspect of tank draining is that it's very geographically dependent as far as how often you will have to do that. So we call it out in our maintenance instructions as to how frequently you should do that. But again, what's it called? The amount of moisture in the air is going to dictate how often, and the size of your tank is how often you need to empty out the tank. So the difference in the frequency with which you need to do that in the mountains in Colorado versus the somewhere in the Orlando area are vastly different. I mean, we have customers in Florida ask us why there's not just an automatic drain valve on there, which we do make and can offer for anybody who wants it. But I say because not all of our products go into hugely humid areas like that, because the guy in Colorado doesn't necessarily need that. So it is something to keep an eye on. And just like I'm talking about with the changing of the oil, right? The oil, it's nice to say, hey, once a year, do this. But the fact is, that's not really always going to be the case, right? It's going to be dependent on the frequency with which the compressor runs. Well, that's also the case here with the pump and tank. It's the frequency with how much humidity you have. Again, I'm talking to you from my 10,000 square foot mansion, apparently, in the Philadelphia area. I just got to find the other 9,500 square feet of this place. But anyway, in the Philadelphia area, in the winter, it's very, very dry. So you wouldn't be accumulating much moisture. But in the summer, it's very, very humid, and you're probably accumulating quite a bit. So in the winter, you probably don't need to empty your tank out very often, but in the summer, you need to empty your tank quite a bit. So hopefully that helps, but you're right. There is nothing in there that calls out in NFPA 25, and maybe there should be. So maybe that's something that we need to talk about. So great question. Anything else, Dave?
No, that's it for now, Ray.
Okay, good stuff. All right, so let's talk about the different types of compressors that are available. Let me see how much time we got here. I don't want to keep you too long. All right, we got about 10 minutes left. Let's see, what do we got? Let's skip over that and just get into what is and is not a fire protection air compressor. So first, one of the ways that I like to talk about this is by way of this light bulb comparison I've been using for years. And you have the light bulb that kind of goes in the lamp in your living room, and you have the light bulb that's in the headlight of your car. And each are designed very specifically for certain applications. And essentially, I mean, it's a little different and they don't look alike, but they have all the same parts, the same components, and the same basic function. But they were designed for very different applications. And that is, even though they look very much the same, the air compressor on the left, our air compressor for fire protection, and the air compressor on the right, for a retail air compressor, they look very much the same, but they are actually very different in the same way that the light bulbs are different. Each was built for a specific application and only works well when used in that application. So, again, you wouldn't put the light bulb from the headlight of your car into the lamp, and you wouldn't put your lamp on in the headlight of your car. It's, could you make it work? You could fool around with it, get it in there, get it to work. Sure. But is it a good idea? It is not. They're not going to work well in those applications. And it's the same with the air compressors. They're just not designed to be interchangeable like that. Fire protection air compressor will have a smaller horsepower. And, I'm going to move on from that one because we have another slide where I get into horsepower versus flow, which is, I think, really important. So we'll talk about that as well. But let's go through to define some of these differences and ask a few questions. Is the air compressor specifically designed by the manufacturer to meet NFPA 13 dry system requirements? So the requirements that we talked about, 30-minute fill-up time, 60-second water delivery time is another part of the requirements. We don't want to impede that by way of having too much airflow or not having an air maintenance device, things like that. So what compressor is ready to go with that stuff? Well, a fire protection air compressor obviously is. Other fire protection air compressors, anything that calls itself a fire protection air compressor will be able to meet these requirements. Anything that's a retail air compressor was not designed for these requirements. And again, you're going to have to make adjustments in order to make them work. Will they work? Potentially. But again, the lamp from the light bulb from your lamp will work in the headlight of your car. You pull some wires out, you duct tape it up there, it'll work, but you're not going to get real far before it breaks. And it's the same thing with retail air compressors. You're not going to get real far until they break. Is the air compressor UL listed 1450 UL listed? And I got to change that to VDUR because there's a very specific listing. See, UL 1450 is a broad air compressor listing. It lists air compressors that are used in concrete facilities. It's air compressors that are used in industrial plants, air compressors that are hundreds of horsepower, all sorts of different types of air compressors are listed under there. But there's a specific listing for fire protection, which is 1450 VDUR. And VDUR calls out some certain requirements that are unique to fire protection. So General Air Products has our compressors listed under UL 1450 VDUR. Gast also has their compressors listed as 1450 VDUR. Retail air compressors are not listed for 1450 VDUR. So here's this note on VDUR, right? We have our listing here. And that's what I said, it's a broad category code. But this one calls out, this category covers air compressors intended for use in sprinkler systems. This is the VDUR part of 1450. When installed in accordance with NFPA 13, installation of sprinkler systems, when the compressor airflow capacity exceeds the limit referenced in NFPA 13, an air pressure maintenance device or suitable flow restrictor should be installed. So this is, again, this is making it very specific to the fire sprinkler industry and use in the fire sprinkler industry. Something else I'd like to call out here, because we've seen this on quite a few compressors that are on the market, some of which call themselves fire sprinkler air compressors, and they say conforms to 1450. Conforms to 1450 is not listed as 1450. And I don't know what conforms to 1450 really means. If it conforms to it, send it to UL and they'll approve it. But the thing is that I don't think a lot of these ones necessarily can, are 1450 listed. So it's something to keep in mind. Yeah. So let's see, what else do we got here? Does the air compressor warranty cover commercial or industrial use? Again, I bring this up because the warranty of a product tells you what it was designed to do. And if it's not warranted for permanent installation, fire sprinkler use, things like that, it wasn't meant for this application. So again, our compressors and some other compressors that call themselves fire protection air compressors are warranted for use in this application, but retail air compressors are not. And one of the, I have a couple of manuals here that I pulled some information from. Any use of these units outside of what's described there will void the warranty. This is a Campbell-Hausfeld one. Campbell-Hausfeld, now understand, they make air compressors that are retail, they make industrial air compressors, and each of those is going to have things that covers, they're covered by different warranties. So it's something to keep in mind. Is it one of their industrial ones? Does that say it's good for industrial use? What's industrial use mean? Is it good for plant air? What's plant air? So be critical in reading these things to determine what they're used for. Another one, this is Craftsman. So Craftsman is almost exclusively a retail style air compressor, to my knowledge. And it says the 1-year warranty is void if this product is ever used while providing commercial services. So they're saying even a guy who's running his own, handyman kind of operation or a painter or something like that, that they should not be using the Craftsman air compressor that they sell at Home Depot or Lowe's or wherever, because they're not meant for, they were not designed to be used for commercial use. They're used for screwing around in your garage with some air tools and stuff like that, for home use, personal home use. And they're certainly not involved, designed for fire sprinkler systems. Let's see, where else we got? We got just a couple minutes left here, so let me skip to the good stuff. Let's see. That's the technical support, and I hit on that, and our people are the best, and they are the people to call on. We have everything in the box. We have great pressure switches. Okay, so here we go. I was talking about this before, and I'll end it with this part here that kind of this is more for service people, I think, in the field and people who service the compressors. But understand, when a compressor goes down and you have a retail air compressor, and one of the big differences between a retail air compressor and a fire sprinkler air compressor is flow. Okay, so if you'll notice here, our horsepower for this GAP compressor and this retail air compressor are the same. They're both 1.5 horsepower. But if you notice on the bottom line, we have more than twice the flow out of the GAP air compressor than we do out of the retail air compressor. So what that means is, let's see, where do we got this? Here's a better way to look at it. If you're at a job site where you have a retail air compressor installed, and you go in there and you're like, okay, this thing's about to crap out, or Ray Fremont made a great argument, and I'm convinced that this is not the right thing to have on here because it's going to fail at any time. I'd appreciate that. So at that point, you want to replace that retail air compressor. Instead of looking at the horsepower that says it's a 1 horsepower, 2 horsepower, whatever, look at the flow. What is the flow of that unit? Because oftentimes what you're going to find is that the flow is, say, 5 CFM, and you match that up to a fire sprinkler air compressor, whether it's ours or somebody else's. And fire sprinkler air compressors are designed to maximize flow. We want to have the most flow possible with the smallest horsepower possible. So what that's going to do is save you a lot of money, because the air compressor that you would call into your supplier to buy, you're saying, give me General's 1.5 horsepower. Well, you only need General's 3/4 horsepower, because if you match up the flow, if you match up the horsepower to horsepower, you're going to pay a lot of extra money for flow you don't need. Now, I'm never against oversizing an air compressor, but that said, you don't necessarily have to, especially by twice. So I would certainly say, look at flow. Don't pay attention to horsepower when you're talking about fire protection air compressors. Look at flow. We said 5,000 run hours out of retail versus 5,000 to 8,000 run hours out of fire sprinkler compressors. That's hugely important, but this really hits all the high points. Dave, any questions?
Yeah, one more you can answer really quick. Somebody just wants to know, in an emergency, is it acceptable to use a non-UL listed compressor temporarily?
Great question. Right now, yes, it is. And I know as we go forward and try to reshape code to get this more specific, I would like to allow that, because I think that it is important. You know, if you have a retail air compressor in your shop or on your truck or whatever, and you're at a job site where the compressor goes down, the fire protection air compressor goes down, if you don't use that, you're going to have to sit fire watch. So that's not a great thing. So I would highly recommend, using a retail air compressor for a couple days, until you get the fire protection air compressor replaced or fixed. So yeah, right now code does allow for that. And I hope that it will stay that way, because it should, because from practical purposes, that's the best way to go. But again, using it for 2 or 3 days versus using it permanently installed are wildly different. So, but yes, good question. And I believe yes is the answer. Is at least that's how we go about recommending it to people. So if you have a retail air compressor, don't throw it away, just don't permanently install it. Any other ones, Dave, or are we good?
No, that was it, Ray. We're good.
Right on, great. Okay, so a few more plugs as we wrap up here. Hopefully that was good for you. I know it's throwing a lot of information fast, so again, never hesitate to reach out to me. I want to give a little plug for our training center. We have tons of equipment in there. You can see all the different people who included their equipment in our facility. So we have wet valves, dry valves, we have residential pump and tanks, we have obviously all of our air supply equipment. We have a fully functional NFPA 20 fire pump and fire pump controller. We can run hose monsters. We can, there's all sorts of stuff that we can do in this training room. It's not just air. And we take full advantage of that. We have backflows in there. We do a lot of backflow training. And what we do is we bring in the experts to do that training. And we bring in people like John and Kevin to do presentations and stuff like that. Obviously we stick to what we know, which is air, but we make it a big, couple of days where we do all sorts of training on all sorts of equipment. So keep an eye out, and we'd love to see you in there. This is my email again, rmfjr@generalairproducts. Please do use it. The 800 number again, please do use that as well.